So far, you have only seen procedures that select data, but we can also use procedures to insert, update, and delete data. In this lecture, we're going to create a procedure to update an invoice. And as part of this, we'll be looking at parameter validation to ensure that our procedure doesn't accidentally store bad data in our database. So let's start by creating a new procedure. We're going to call this make payment. Here we need three parameters. First is the invoice that we want to make a payment for, so invoice ID. And the type of this is integer. The second parameter is the payment amount. And the type of this parameter is decimal of 9 and 2. What is this? Decimal represents a number with a decimal point. Here we have two arguments. The first argument represents the total number of digits, and the second argument represents the number of digits after the decimal point. Okay? And finally, the last parameter, that is payment date of type date. All right, now let's write a SQL statement to update the invoice with the given ID. So update invoices. Let's give it an alias. Here we set i.payment total to this payment amount parameter. And we also set payment date to this payment date parameter. And then we write a where clause where i.invoiceID equals this invoice ID parameter. Here we only want to update two columns because when the client makes a payment, we don't want to accidentally update the invoice number or total amount or the invoice date. We only want to update the payment total and payment date columns, okay? All right, let's go ahead and create this procedure. Here's the generated code. Beautiful. Let's go ahead. Done. Now let's call this procedure. So I'm going to call it right here. Let's set the parameters 2 for the invoice ID, 100 for the payment amount, and let's say 2019, January 1st for the payment date. Let's execute this. So this generates a call statement like what you see here. Now let's go back to our invoices table and verify that our invoice was updated properly. Here's invoice number 2. And as you can see, the payment total is set to $100. Beautiful. But what if we pass a negative value when calling this procedure? Let's execute this statement and see what happens. Back to the invoices table. I'm going to refresh. You can see we have stored minus $100 in the payment total column. And that is not good. We shouldn't store invalid data in our database. So let me show you how to validate the arguments that we pass to this store procedure. Back to our procedure. Before our update statement, we're going to use an if statement to validate the payment amount parameter. So if payment amount is less than or equal to 0, then here we should use the signal statement to signal or raise an error. This is like throwing an exception in other programming languages. So we type the signal keyword followed by the SQL state keyword, and then a string literal that contains an error code. Where do we find the error code? If you search for SQL state errors, you can find the complete list of these errors. Now here we have different pages for viewing the complete list. I personally don't like the one on oracle.com. It's poorly formatted. The one on IBM.com is better. Let's have a look here. The first two letters specify the class of the error. For example, 22 represents a data exception. Most of the time in stored procedures, we want to deal with out-of-range values. And there is a standard code for that is 22003. Let me show you. So I'm going to search for 22003. These are all the errors in the category of data validation. So 22003 is the standard code for a numeric value that is out of range. And that's exactly what we want. So back to our procedure. Let's set the error to 22003. Note that this is a string, not a number, okay? So this is how we can signal or raise an error. Now we need to terminate this statement with a semicolon. Here we can optionally set an error message, and this helps the caller of the procedure identify why something failed. So it's a good practice to set a descriptive message here. So after the code and before the semicolon, we type set message underline text equal to, let me break this down to multiple lines. That's better. So let's type a meaningful error message here like invalid payment amount. Okay. Then we terminate this statement with a semicolon. And finally, because we have used the if statement here, we need to terminate this block using and if. So this is how we can validate the parameters of our store procedures. Now let's test this. First, let's apply the changes. All right. Beautiful. Now back to this other query window. If we call this procedure with an invalid payment amount, we get an error in the output window. So it's a good practice to check the parameters of a store procedure before making any changes to the data. But of course, too much of a good thing is a bad thing. If you write too much validation logic here, your store procedure will end up looking very bloated and it will become hard to maintain. For example, here I'm not going to check to see if this parameter is null, because the payment total column doesn't accept null values. So if you pass null to this procedure, MySQL will automatically signal this error. We don't have to do it. So keep your validation logic to the bare minimum, the absolute essentials. You should do a more comprehensive validation in your application at the time you receive input from the user. It's much faster to detect and report these errors in the application before hitting the database. Do parameter validation as the last resort in case someone directly calls your store procedure without using the application.